Hey, my name is Shrey, and today I'll be explaining question 2 from Leetcode's most recent biweekly contest 32. And question 2 is, can convert string in K moves? So, just a personal opinion, I thought this question was actually harder than a typical question 2 for Leetcode, and the wording was just really poor and it took me a lot of time to understand. So, I'm going to be explaining all three examples to clearly explain what the problem is. So just some background. The question gives you two input strings, and your goal is to see if you can convert string S into string T. And you can convert a string by shifting a character, and what shifting a character means is that, so what shifting a character means is that you just replace it with the next letter in the alphabet, and then wrap Z all the way back to A. And you're given a maximum of K moves to do that in. So if you can't do that in K moves, then just return false. So yeah, that's a little bit confusing, but I'm just going to explain what that means in relation to these three examples. So example 1, we're given two input strings, S and T. So we see that we have to switch input to output. So these three characters are fine, so we don't really have to change these, and we're more worried about the first two characters. So first we have to switch I to O, and we can shift it 6 times. And what that means is that you start from I and then you go J, K, L, M, and O, and then from I to O would be 6 moves, so yep. And then we move on to N, and we have to shift N to U, and we can shift N to U in 7 moves, just going one letter in the alphabet each time. And as you can see, 6 and 7 are both less than 9, so we just return true. This example is pretty straightforward, and let's move on to example 2. We have to shift A to B first, and yes, we can do that in 1 move, which is less than 10, so that's good. Now we have to switch B to C. That also takes 1 move, but here's the tricky part. You can't repeat a move more than 1 time, because you already used 1 time to switch it from A to B, so you have to shift B to C in a certain amount of moves, which is not 1. And the way you can do that is you can go from B all the way to Z, back to A, back to B, then back to C. So there are 26 letters in the alphabet, so if you go from B to B, which would be 26, and then going again from B to C, which is 1, so this is 27 now. And here you can clearly see that, hey, 27 is greater than 10. So that means that, no, we cannot successfully shift string S to string T in the given amount of moves. So we're just going to return false here. So let's move on to example 3. Same thing, shifting A to B. We can do that in 1 move. Now we're shifting A to B again, same thing in example 2, and we saw that it takes 27 moves. But our maximum amount of moves in this example is 27, so that's good. And then finally, B and B are the same, so we don't have to do anything there, and we would just that was kind of bad, and we just return true. So yeah, that's just explaining the entire question. I really wanted to go through all 3 examples just so you would have a more clear understanding of the question. And let's move on to the solution now. I'm just going to copy paste this example 1 right here. Yeah. So let me just label this example 1. Great. So one more thing is I'm just going to write solution right here. So now we're going to move on to the solution. So the first thing that we need to do is, some background. I solved this using a hash set originally, and I got a time limit exception during the competition, and then I optimized the solution in terms of time complexity through a hash map. So the first thing which I did was I dealt with the edge case, and I did that by saying if the two lengths of the string aren't equal, then I mean you can't shift string S to string T. So if if lengths are not equal, then you just return false. Just dealing with that original edge case. So now what I did was I declared a hash map. I'm going to use hash map, and I'm going to use HM to denote it. Declared hash map of the difference and frequency difference. And I'm going to explain what both of these two things are in context to the question. Just stick around for that. So now what I did was I had to go through each character in the string. So for each character in the string. And the first thing I asked myself is if the two characters are equal. So in example 1, P and P are equal, so we would just move on to then U and U, which are equal. So one thing we know is that if the characters are equal, then we don't really have to deal with that. We can just move on to the next character. So I said if characters are not, actually I'm just going to say if characters are not equal, then we want to execute the code down below. Otherwise, we can just move on to the next character. Yep. So so after I asked myself if the characters were equal or not, I moved on to calculating the difference. And what difference is that the difference between O and I is 6. The difference from U to N is 7. So I just took difference of both characters. So that's what difference is, and we're going to be storing that in the hash map later on. And then one more edge case, once you calculate the difference, is that say that this character was O and this character was I. Well, then you would have to go from O all the way to Z, back to A, and then all the way back to I. So what we can denote from this is if the difference is negative, then we just say difference plus equals 26. Because if we had to go from O to I, it would take 20 shifts and not 6. But it would be 6 in this case because we're going from I to O. Great, so now we dealt with the difference case, and what we should be left with now is a positive difference, basically. So the next thing we have to ask ourselves is if the hash map, if hash map does not contain the difference, what that means is that when you originally start off and you're on this first character, I equals 0, you have I and O, and the difference is 6, and that's not in the hash map. So we're just going to say HM. Let me be consistent and write HM. So then we're just going to put the difference and the frequency. So if it's not, if hash map does not contain the difference, then we're going to put in the difference with the frequency of 1. And else if the hash map does contain the difference, and I think that would better be explained through example 3. Our first character A to B is 1, that's good. That's not in the hash map originally, and then we go from A to B again, and hey, 1 is already in the hash map. So else, what I said here was I put the hash map again, I put the difference, but I incremented the frequency of it by 1. So in example 3, the frequency would now be 2. And finally what I did was I said if frequency formula, actually let me just, I'll explain that later. So frequency formula is greater than K, then you just want to return false. So let me just explain what the frequency formula is. So this is a frequency formula right here. It's the frequency minus 1, frequency minus 1 times 26 plus 1 is the frequency formula, and that's what I'm just calling it, the frequency formula. And what the frequency formula is that if you already have a hash map with a frequency which is greater than 1, and let's just look at this through example 3. So a to b is 1, and then a to b, again, we would put 1 with the frequency of 2, but we wouldn't have 1 as our difference. We would have 27, because the reason is the frequency is 2, so 2 minus 1 is 1. 1 times 26 is 26, and then 26 plus 1 is 27. So this formula will work for any case when the frequency is greater than 1. And so in example 3, this would result in 27, and the reason that was okay in example 3 was because the maximum number of moves was 27. But if we did the same thing in example 2, we would also have the frequency formula resulting in 27, and 27 is greater than 10, and that's why we returned false. So that's why I have this extra check right here. Finally, what we want to do is we're going to break out of the loop, and if we can successfully get through the loop without returning false, then we're going to return true. Yep, so there's actually one more thing I left out. I'm just going to add that right here. I'll just call this 6a. So one more check I forgot to leave out. One check I left out was if the difference is greater than k. And what that means is that if O minus I, or let's say this was z actually. So if z minus I, which is obviously greater than 9, then we would have to return false because we wouldn't have enough moves to go from I to z. So that's why before you deal with this hash map situation, you have to ask yourselves if the difference is greater than k, you want to return false here. Yeah, so that's just something I left out. But I mean, besides that, that's the entire solution. Yeah, it was a little bit tricky just dealing with the entire hash map and frequency situation. But once you understand the hash map situation, it becomes pretty easy. As always, if you have any questions, just leave them down in the comments below. And if this video helped you in any way, please remember to leave a like and subscribe, and I'll see you in the next video. Thank you.